Yep. If you are ready, let's proceed. So what we'll be talking today? Today we have three topics to cover related to the interfaces, lambdas, and inner classes. So uh, you already were working with a home assignment where a lot of abstract and inner class and interfaces were included. Yeah, and let's start to think and try to identify a difference again among the interfaces and abstract classes and why we are using them. So I would like to keep you a proactive mode working on, and people offline, people online, please jump into this discussion, and yeah, who can explain the difference.
Interface is not a class.
Mhm. That's true. Okay, and what else? Why we need interface? Because interface, as you probably know, it has method definitions like here in example, start, stop, even some default implementation could be described here. What is the
Class
main?
can class can implement multiple interfaces while extend only one class.
That's true. Okay. Any other differences? But yeah, let's not waste the time. Let's go to the work. So you, Andrei, said everything correctly. We cannot extend multiple interfaces, multiple classes. We can extend multiple interfaces. So why is that? Because potentially it provided a lot of issues in languages like C++ or others who provide this capability. And of course, as you can see here, that the bicycle could be extended by multiple other classes. It could be like rechargeable class or some other classes. And in case when we have the multiple extension, it provide the issues in case which kind of method implementation shall we call from the parent class. Java language, as well as C# at some point of time resolve it by introduction of the structure called interface. Interface, it's actually the structure where you can find the method definition without its implementation. So like here, for example, you can see the interface rechargeable. It has the method charge battery without implementation. And in case you have electric bike as an entity, of course, it extends the bicycle because it has pedals, it may have wheels and other attributes, but electric bike has an additional actions to work. So we can charge, recharge it, we can change the battery or something else. In this case, we are extending the behavior of electric bike by extending the bicycle itself and implementing additional interfaces which can be reused and re-implemented in the electric bike class. So here we have a bicycle as a parent class. We have pedals. This everything is extended to the electric bike. And yeah, we are adding additional logic and saying that in case when electric bike implements this rechargeable interface, it should also provide the implementation how to charge the battery. As a result, we have subclass electric bike. It implements rechargeable and it's required to implement the method charge battery. So we are saying that electric bike should also have some features and method from the rechargeable interface. And we are requiring to implement it in electric bike. So Java doesn't offer the option to extend multiple classes, but Java provides the possibility to implement multiple interfaces. It could be rechargeable, replaceable, anything you want. depending on the situation and the business logic you are going to implement. Is it clear? Any questions? Good. So, what it brings to us? You also were working with the cases when you assigned to the parent class definition the implementation of the subclass. So you had an example when parent class A equals new subclass. The same works with interfaces. In these examples, you can see the capability to assign, first of all, parent interfaces as to the parent interface definition, the whole object. It's also possible. As well as here in the parent example, we can define electric bike as a typical class. So let's go one by one. Here we defined electric bike class. It has everything defined in the class structure plus interface. It has pedal, it uses a motor, and it has a charge battery. So everything defined here would be in electric bicycle class could be called. And additionally, so we are setting rechargeable as a device, as an interface definition. We are setting the electric bike. So interface definition would also be instantiated by the class which extends it. So here we can join all of rechargeable devices. It could be electric bike, electric car, whatever. Everything which implements rechargeable interface could be defined in this way. And this is a kind of abstraction. Here we can call device charge battery. So it's an abstract way how to call precise implementation of your object. As electric bike implements rechargeable interface, has a definition of charge battery, it's possible to call it from the interface definition. And in this particular case, we will charge the battery. The question is, in case when we call device use motor, it will call the error. The question why? Do you have any ideas? Okay, let me explain. Java looks here on the interface definition. Device is actually an instance of the interface. It's instantiated as electric bike, but for Java, it's rechargeable. And rechargeable interface has only the method defined like a charge battery. Rechargeable interface doesn't know anything about motors and other attributes. So here, in case you will call use motor, it's not defined in rechargeable interface. It will call an error because method is not defined itself. So charge battery is callable because it's a part of rechargeable interface and it's implemented through the electric bike. But use motor is a part of electric bike itself. So its rechargeable interface doesn't know about this implementation. That's why it's calling an issue and calling an error. Good.
But how can we define rechargeable as a new electric bike?
Actually, as it is, like here. So let's go to the idea and try to practice. I'm not sure if it's there, but let's create it. We have interface rechargeable. I believe you can see my screen.
Yes.
We have void recharge. Yes, sure. Give me a second. You're welcome. Yeah, so in this way, we are defining the interface. Charge. Right. Let's create another one. Oh, sorry. That's the wrong number. Appearance, that's exit first, and I'll create class infrastructure like bicycle, electric bike. Add bike itself. And let's proceed. So we have electric bike. Electric bike can extend the bicycle and implement rechargeable. Yeah, so we can also add some default method. It shouldn't be the issue. And here we are saying system out println recharge. Good. Bike has also its own method like void has motor. Good. Let's go to the main application. For example, we have electric bike. B equals new electric bike. EB, so what we can call recharge and has motor. Let me extend a bit. Yeah. So we can call has motor, we can call recharge, because everything is packed in this definition of the object EB. It's electric bike. Now, let's call rechargeable R as electric bike. Well, it's also possible to set because electric bike implements rechargeable interface. So everything in electric bike has a definition is rechargeable interface, but we cannot call has motor. It has hash code, but has motor isn't there. Rechargeable interface doesn't know details of the implementation of electric bike. It knows only about the recharge method. Yeah, because we defined it as a parent interface of this implementation. Is it clear now, or I need to explain more?
More or less clear.
Yeah. So in case if you are instantiating your objects as parent interfaces or parent classes, you from this object you can call everything which is defined here, but not in the details of the electric bike. Nevertheless, don't forget about the casting capabilities. Always you can do like that. Of course, if you are sure about the type of your object. Yeah, here we are saying that R should be instantiated like an electric bike. And we have the variable EB2. And EB2, as an instantiated object of the electric bike, can get the information about motors, and also it could be recharged as well. Yeah, instantiations actually covered during the previous lectures. You can remind it, but here this is a crucial. So only defined methods and in interfaces could be called in case we are instantiating in this way. Good. Any other questions? If not, let's proceed. Yeah, here we actually just checked in idea why the second example will provide an error. And let's go deep into the interface syntax. It's important to know. So what we can define in interfaces? We can define constants. It's a common practice to define some commonly used constants around your application, like here. We have int max charge time equals to 120. So it's possible to define and instantiate variables directly here in interface. Also, we are defining the methods without implementation, void charge. So this syntax says that interface has this charge method. All of classes which implement this interface should implement this method. Also, it's possible to have the default method implementation. So for example, you are not sure if every class implements this interface. It's possible to provide the default implementation. So in this case, if nothing being extended in your child classes, then this implementation will be called. This one is added for the backward compatibility in your application API. Static method also possible to define and implement on the interface level. So for example, display max charge time. It could be a part of this interface. So in terms, when we are implementing the interface, we should, of course, provide the structure of the method which should be implemented and provide the detailed implementation. So instead of using extends keyword, we are using implements. Smartphone is also a rechargeable device. And here we are saying the rule and business logic how it should be charged. I think it's clear. If any questions, please raise your hand. Good. We have some even advanced cases, and one of good example is a comparable interface. So you remember from previous lecture, we were talking about collections and list and generics being used there. Also, there is an interface comparable. What does it say? It says that some of objects could be compared. So, for example, here we can provide objects of class student and compare them by name, by age, or anything else. Details depends on your implementation. So it's being actively used in the Java Collections API in case when we are having collections which should be compared, like lists or sorting in a list. Also, data structures like set, tree set, hash set. Sorry, hash set not, but tree set, it's importable. So implementing this interface means that we are comparing objects of this class by implementing some of these rules. So as you can see, it contains the integer. So it contains only one method compared to the same objects of this generic class. And yeah, it provides the integer, and the rule is simple. So in case when compared to provides a negative value, the current objects of this class is less than objects passed here to the compared to method. If 0, they are equal. If return value is positive, then the current object is greater than the object passed. Let's take a precise look on our lovely and widely used class animal. So what we are saying, we can say that animals could be compared. And yeah, we are implementing comparable interface, saying that we are comparing, also, of course, by animals. And we're using typical fields like name, weight of the animal. We are providing constructor and some other widely used things like getters of the name and weight. And here we are implementing the comparator method. As an input, we are getting the animal, and yeah, we are comparing these animals by weight. So we are reusing double compare because weight is a double value, and we are checking if the weight of the current object is bigger or lower or equal to the objects which is provided as an input to this comparator. Is it clear?
Yes.
Good. Any questions? by wrapping up. Comparable as an interface says the rule, general rule, how the values could be compared. By implementing this interface, we are implementing the common method, which could be reused in any other main Java API, mainly in Java collections. By comparing values, we can sort, we can order in ascending or descending order, and so on and so forth. This is general rule how objects should be compared. And it's very widely used interface. Good. Yeah, here we can see an example of using of the comparable interface. Yeah, let's check the main implementation. We may have animals like elephants, dogs, cats, bears, and in this example, we are creating a set of animals as you already performed in your home assignment. And we are actively using the comparator method. Let's check here. We are creating an elephant. Elephant is, of course, a heavy animal. We creating a dog. Dog, well, weighs maximum 30 kilograms. Here we are calling the dog compared to elephant. We are saying literally that please compare the dog with the elephant. If it's a bigger than 0, then dog is heavier. If not, then vice versa. So what is going on here? Compared to, as you remember, returns the integer value. We are comparing one to another. Of course, dogs couldn't be heavier than elephant. Probably we will get the negative value in response of this method. So we are comparing it with a 0 and having the Boolean as a result. So actually it's an answer. Is dog heavier or not? Here in the system out println, we are getting the response and probably we'll have the false here. That's how we are using. And that's actually could be used in any other instance of the animal class. Elephant, dog, cat, bear, and so on and so forth. Java Collection API, as I said before, offers the possibility to sort them by any rule implemented in comparator. In this precise example, we will sort by weight. Yep, actually collection sort of animals will use the interface as an input and check if this collection has the comparable elements. If yes, it will sort it by performing comparator method we are implementing in our class. Let's go back to the code and check how it works. So first of all, this one should be removed. And yeah, let me open up the presentation mode. And here we have the implementation. Yeah, we have animal, name, weight. We are instantiating, we are implementing this comparison logic. So let's try to execute and check the result. Good. So what we have, as I said, dog, is it dog heavier than elephant? No, of course not. This part is here. And what we got in result, we have a sorted list of animals. We created them in a random order, but here we are sorting, collection sort animals, and providing an output. This one, sort method, sorry, let's go back to the main. As you can see here, it expects to get the comparable collection. It uses this logic inside of the roots of Java API. That's why it's important to implement comparator. You can compare even by name and probably sort in by first letter, whatever you want. All of these details should be implemented here. And definitely, in case we'll provide a dog as a heavy one, let's check 3000. Yeah, elephant. The dog now is heavier than elephant. Yeah, okay, it's funny, but that's how it works. In case I'm providing a bigger weight for the dog than elephant, it compares here. And now this value turns from the false to true. Any questions here? If not, let's go back to the presentation itself. Yeah. Event handling for the custom objects. That's also a good example and a part of your next homework assignment. And it's also widely used in using interfaces. So let's go first of all to the app itself. We have this Click app. Let me try to run it on my PC and check what is going on. Yeah. Oh. Look, we have JavaFX application. I hope you can see it. Currently, at the starting point, we have a label and a set of controls. 1, 2, 3, 4, 5, 6. The label says that we are not selected anything. Now we are clicking on a control 0. It says select control 0. Selected control 2, 4, 5, 3, and anything we will click here. So how it should work? Of course, on the JavaFX level, we have a general component which extends the paint level. We will take a look on it in details. We should have an action. So when we are clicking on any kind of this object, it should react and change and handle this label name. So we should pass and handle the state of this label after the clicking on each of this control. Let's check details of the implementation. Yeah, so here you can see the example and how our app will look. So previously you were working with UML, and with UML it's always a good practice to visualize the main logic and class structure in your app. And yeah, so we have click app, we have click handler, and we have a custom control. Let's start from the click handler. Click handler is an interface. It has only one method handle. Method handle is responsible on actions performed after the clicking on this control. In fact, it will be changing the label in your app. Click handler is being used in a custom control. Custom control actually is this pane. It will extend the pane class from the JavaFX. It will have click handler interface instance. It will have text, and it would be possible to set a click handler inside of it. Custom control itself will be used in a click up. Click up, well, it's obvious it will have main start objects like a typical JavaFX application. It will build the set of these controls, and yeah, the application should react on your actions. So three main components here: handler, control, and application itself. Let's check interface click handler. So actually, we are not implementing anything here. We're just saying that click handler should be responsible on any kind of actions after clicking the button, and every logic should be implemented in classes which implement this click handler. And also, in case this interface has only one method, we can call it as a Lambda expression. So in case we have a single method without any implementation, it's possible to define it anonymously and say, define it as a lambda expression. Lambdas were covered during the first lecture. Some of advanced examples we are currently reviewing. Usually these interfaces like click handler, suppliers, function, B functions are calling us a functional interface. Functional interface is an interface with only one method implementation. In this case, it's possible to define the logic by using the lambda expression. Yeah, let's check precise implementation of all of these three components. Let's start from the custom control first. As I said before, it extends the pane and it has a click handler, it has a text. It has details of the UI components, how they are built. So we are saying the color, we are saying the sizes and all of the things to put all of these UI elements on your application. What is interesting here? We are setting mouse click. So set on mouse click, we are getting the event and checking if click handler is defined. If yes, then handle the action. Additionally, we have set click handler method to provide precise implementation and get the text of this control. Click handler interface, as we checked before, defined like an interface without any kind of implementation. Let's go back to code. I think it would be much easier for you to understand. So we have this click app. Let me go back to the presentation mode. Yeah, and we have the main application. Yeah, we have all of these definitions related to the position of elements. Let's go to the custom control. Click handler here, text is here, mouse on click is an action. And how we are calling here? We are calling here as a lambda function. Mouse event, again, it's another one interface with only one method inside of it. Yeah. Go back to the click handler itself. Yeah, click handler is an interface with a handle class. And we are defining them. So first example, defining it as a class which implements click handler. We are saying control clicked. So when you are clicking, handlers put in the console that we are clicked on it. In addition, we can set it as an anonymous clause, like here, and provide the same implementation. Anonymous class, these are classes when we are saying new click handler and provide direct implementation of the method which is needed here. In addition, we can set the control click handler as a lambda function. This example provided here. Why we can use lambda? Because click handler is a functional interface. So for Java, it's pretty understandable which method should be called by the definition from the interface, and details of the implementation could be defined in this way as a lambda function. Any questions here? Is it clear? Because topic is quite tricky. Okay, good. So the question to you, audience, which method is most preferable for you? We have actually even 4 options. 2 for lambdas, 1 anonymous class, and 1 in case we are extending. Which one is the best in your opinion?
Probably the first lambda because it's the shortest.
Good. Why not a second? It's also lambda, yeah. What is the difference between this lambda and this one?
The first lambda gives us just the sounds, but in the second one, with this curly braces, we can implement more functionality.
Mm-hmm. Yeah, you're right. So here in these brackets, we are just can provide only a single row of implementation. Usually it's enough. But in case you have something like multiple rows, system out, print room, hello, and other things, then you need to provide the curly brackets and provide details of this complex implementation in curly brackets. Yeah, I also prefer the first one. Sorry. But the first way of working arised from the Java 8, when Lambda functions appeared. Before Java 8, the typical way of defining all of the things were anonymous classes. And also it was quite common to see these ways of implementing custom interfaces. So in case you're working with old application without Java 8 support, it still happens. You can widely see these cases of calling them anonymous methods. Yeah, but the most preferable is this one by defining this handler as a Lambda function. Good. So, is it clear? I think yes. Let's go back to the presentation then. And actually, yeah, it's details of the implementation we currently discovered. So we have setters to define the handler. We have the possibility to get text. We have the details of the implementation of the control. And we have a general interface click handler. And yeah, we have Lambda variants. As yeah, we define our general control. It could be defined as a typical Lambda function with the possibility to provide more complex logic and multiple rows, anonymous class, and the extension of the click handler and implementation of logic in a separate class in your app. Both four variants are right, correct. Most preferable is the first one if the logic is quite simple. So in this way, we are setting the click handler. We are setting the reaction on the click by providing our custom object. Yeah, so here we have custom control. It's our current control, which collects all of these controls in your application. And yeah, our application is, as I said before, quite simple. We have the pane, we have a label with default values of no control selected. We set in some fonts and other things to display the status and highlight. So in this way, we are defining our app as a basic JavaFX application. And yes, setting our custom control, which is selected by using this private field. Now, we need to instantiate all of these objects. We have custom control, like new custom control plus I. So this is a cycle. In a cycle, we are creating 7 objects of the class custom control. We are well positioning them on a pane here. So currently positioned one by one. And for each of the custom control, we are setting the implementation of handle methods like a lambda with a custom and quite complex logic. So here you can see a multiple rows for this lambda function. So what we are saying that handler should set the style of this button and change the color to the red, should change the text that this control is selected. And yeah, if the current control is also defined, So if the previous one should be turned back to the gray, in this way, we are setting the previous one to the state and the color light gray, and saying the current control as a custom control. So we are instantiating variable. So let's go back here. This one is a selected control in our application. So when you're clicking here, this handler setting in this private field currently selected control in your app. In this way, you can get this object and operate with it. By default, it's null because we are not selecting anything. And this logic, this handler just resetting this custom control to the current control in case we are clicking. So this handler is responsible for this action. Let's go back again to the code. I think it would be much easier for you to understand. Yeah, so we have this click app. Let's go back to the presentation mode. Yeah, here you can find the custom control, and here you can find this logic. So what is going on here? We are defined a set of these objects, of these controls, and it's possible to select them by clicking, and we are changing the color. If you are selecting, it should be red. In case if the previous one was selected, it should be turned back to the gray. Current control is the way where we are storing this information about previously selected control. In case when this handle being called, the new object should be passed to the current control, which should point to the latest selected control in the app. That's how it works. So let's go back here and click. So we are clicking on a control one. Control one is already instantiated object and put on this Java FX pane. When we are clicking, then this handler being called. So the first step, put the color to red. Then put the text of the label that control one is selected, like here. We are checking the pointer of the previously selected control and turning back to gray. Again, click on 4. This logic being called one more time, again and again. And with the current control, we always have the possibility to access selected control of this application. Is it clear now? Any questions here? Good. No questions. Let's move on. Yep. So that's the core logic which provides the possibility to select and change and navigate among the controls. And yeah, probably in the next homework assignment, you will have the possibility to implement it by your own and practice, and just recheck on your part how it is working and how to work with controls, and also how to pass the custom handlers and set them on a click reaction. What else we have to cover today? Inner classes. What is the inner class in a few words? Colleagues from the classroom, colleagues online, please don't hesitate to raise your hand and join and provide your answer. Here you can see example. Why we need inner classes? Because it sounds probably illogical, because we can split our app by multiple classes and then put it in a package.
Sometimes we want to see the implementation in the same file, not to lose anything, so everything is just in front of us.
Partially, yes, but any other thoughts? Well, first of all, inner class, it's a class implemented inside of another one class. As here, in example, you have outer class and inner class. Inner class is inside of outer class. And yeah, in the inner class, we can collect and organize some of commonly used logic inside of the outer class. The key feature here that inside of the inner class, we can access fields in the outer class. Like here, we have outer field as a field of the outer class, and we are directly accessing it from the inner class. Why we need it? Yeah, because some of actions, some of handlers, some of other logic could be copy-pasted if you're not organizing well your application in the outer class. And it's possible to adjoin and put it as an inner class, and still will be able to work with the fields of the outer one. So just here, for example, in a display method, you may have some of advanced logic, like visualization, building the controls, providing the common statistics, which is dependent on some external data like outer fields. So the bad practice is copy pasting every time. The good practice is adjoining it in method, but of course, if it's a separate classes, they can be moved as a separate inner class. Inner class is not available by default to the outer world. So we are also encapsulating this object inside of the outer one. And yeah, it helps to organize your logic. Let's check another one example, because here it's a dynamic one. Also, it's possible to provide a static inner class inside of the outer class. Static class, generally, it's a class which contains static methods. We already covered them in previous lectures. And yeah, so like classes mass, pal, p method also collected in this mass static class, and other commonly used methods. So they could be external or separate static class. As well, it could be also collected in a static nested class, like example here. Static classes can access the fields of the static fields of the outer class by default. So in this case, you can implement some commonly used logic which doesn't require instantiation of your class, and can provide some general logic on commonly used helpers method, like in math or like printing or some other things which widely used in your app. Yep, and by default, static classes are available to the outer world. If the public class, if the outer class is a public, it's also possible to get static classes inside of it. Here you can see the example of main application when we are obtaining static class inside of the outer class. This practice is not widely common, but the idea is the same: to organize the logic, pack it inside of logical blocks of your class, and do not repeat yourself in the app. Good. Here you can find some local inner classes. So it's even possible to define them locally in your methods. So in example, we have the outer class, we have the method perform action, and for temporary reasons, we can also define the local class inside of it, and use also inside of this method and instantiate the local class. So local class inside the method can access outer class members as kind of expected, but the scope limited only by the method itself. So it's not possible to extract it from the outer world, from the main method, and call it explicitly. Generally, it's not a commonly used practice, but again, if it's needed, you can implement it in this way. The idea is also to organize your components, objects inside of method, and it makes sense in case these classes is not reused anywhere else. Any questions here so far? Good. Anonymous class. We already saw them in our component application with controllers, but again, let's check it in details. For example, class greeter. So we have an outer class, we have the abstract class, abstract static class inside of it. And as you know, static classes, static inner classes actually are publicly available in case when outer class is publicly available. So we can instantiate it in our main method of the application. Class greeter is an abstract, so it doesn't have implementation for this method greet. In case when we are calling it anonymously, this is a way how example of an anonymous call, we should provide directly here the implementation of this method. So greeter is an abstract class. It doesn't have any kind of extensions and subclasses. But again, if you need it in your app, and if you would like to call an abstract class, it would be required to implement details of this logic in an abstract method inside of it. In this case, it would be possible later on to call greeter greet, and it will work in the way how you implemented it in anonymous definition. Is it clear? I think yes. Good. About use cases. Let's recap them one by one. So each type of inner class has its specific use cases. Yes, someone would like to talk? Okay, no. So non-static inner classes are associated with the instance of the outer class and can access both static and non-static members of the outer class. So we can get static definitions, we can get some fields from the inner class if it's a non-static definition. Static inner class are associated with outer class itself only. So it doesn't have anything to do with the instance of the outer class. And that's why it can access only the outer class static members. Local classes are defined within the method and can access local variables and parameters of the method that are declared final or effectively final. So its declaration of the local classes are inside of the methods. It's not commonly used, but you can reuse this practice in case you need to organize your objects inside of the method. Anonymous class are useful for creating quick one-off objects with a modification to standard objects, or to implement interfaces for abstract classes without a formal class declaration, like with a handler. So we shouldn't create instance of a handler for each of this control. We can call this anonymously. Yeah, any questions? Is it clear for you?